Example 2 asks us to sketch a graph of each quadratic function. So if you were asked to do this on the test, for A, you would have a choice now, because it doesn't say which way you need to figure it out. Either we can do it the same way that we've been doing in this unit, which is writing it in factored form. So if I change this, x squared minus 5x plus 7, does that factor nicely? No. So the factored form isn't going to help us at all in this situation. So what's the other method that we did? Completing the square. If you were completing the square, you would factor out the -2. You would get x squared minus 5x. In completing the square, you only factor out of the first two, right? I'm going to move these over just a little bit this way. So we have space, and you left a space. In the next step, you would have -2. What would be inside what's squared? Will it be plus or minus, first of all? It has to be minus to get the -5. And it'll be half of that, which you can write as 5 over 2 or 2.5. If it's 5 over 2, what number would go in the first blue space? Positive 25 over 4. And what have I actually done, though? That 25 over 4 will get multiplied by that -2 in front, making it -25 over 2, or -50 over 4. And since I've subtracted 25 over 2, I would need to add 25 over 2, which is 12.5. What's -14 plus 12.5? -1.5. So sometimes we like the factored form because completing the square might have fractions. But sometimes we get something that can't be factored. And if we get something that can't be factored, well, then we have to go to completing the square. When graphing, so I'm going to sketch this graph right now. When sketching a graph, you'll need to label your vertex. So in our case, our vertex is going to be at 2.5, comma, -1.5. Will it open up or will it open down? It'll open down. And so we can go over 1, down 2. If I go over 1, down 2, I will now be at 1.5, and down 2 from that will be at -3.5. I don't know if I went quite down 2. There we go. If we wanted to draw and label our axis of symmetry would be at x equals 2.5. So we tried to do the factored form, and we got an equation that can't be factored. Then we went to completing the square to graph it. Okay, another nice point that you could easily label on this one, can you see that you could easily label your y-intercept? Your y-intercept is really easy to figure out because you plug in 0 for x. And so another nice point on this graph is 0, -14. Let's look at example 2, or part B. Can this one be factored? Yes. Okay, but you don't have to factor your 4 out. That being said, so yes, I could factor this one, but it may be that you decide you don't want to factor that one because maybe these ones you're not as good at factoring. Right? So I'll do it the factored form, and I'll also do it the completing the square, and then you can decide which way would have been better for me in this case. So here I factored it to be 2x plus 1 and 2x plus 5. From that, I can find my x-intercepts by setting the equation equal to 0. And you get x equals -1/2 and x equals -5/2 as your x-intercepts. If we start to graph this, -1/2 would be there. -5/2, which is -2.5, would be there. And our axis of symmetry would be here, right in the middle, at -3/2. Does this parabola open up or open down? It opens up. So our vertex, okay, and I'm going to label these points on here. This one is -1/2, 0. This one is -5/2, 0. Our vertex is going to have to be somewhere down there. And what do we know? We know that the x-coordinate of our vertex has to be -3/2. If you plug that back in to your equation, what's 2 times -3/2 plus 1? Here, I'll rewrite this. Bring this. If I plug in -3/2, -3/2, 2 times -3/2 plus 1, and here 2 times -3/2 plus 5, this is going to be -2. This is going to be 2. So our y-coordinate of our vertex is going to be -4. So we can label that on our graph, and we've got our x-intercepts and our vertex, and that's labeled enough to graph it completely. If you wanted to, again, another easy point to label is your y-intercept. You can always plug in 0 for x. If I go back to the original equation, if I plug in 0 for x, can you see that your y-intercept would be 5? So this is factoring. If we use the factored form, we get 2 x-intercepts. We can always find our axis of symmetry right between them. Once you have your axis of symmetry, you know the x-coordinate of your vertex. And you can plug that x-coordinate of your vertex back into the equation to find out what the y value would be that goes with it. if we split our page here and did completing the square, for completing the square, you would factor the 4 out of the first two terms, which would give you x squared plus 3x, and we'd still have plus 5. Again, leave a space here and leave a space there. To get a plus 3, this would have to be plus 3/2. And then in our first green space would be plus 9/4. That 9/4 gets multiplied by that 4. What have we actually done? We've added 9. So in the other space, we'd have to subtract 9. 5 minus 9 is -4. And so we've got our standard form of our equation. Can you see from there that your vertex is at -3/2, -4? So you could already get this point. And then if you went over 1, in this case we need to go up 4, over 1, up 4 would get us right to there, to -1/2, 0. And we get the same points with completing the square. Okay, I'm going to expand this so you can see the entire page. In this case, do you like the factored form or the completing the square better? Okay, if you like the left side, raise your left arm. If you like the right side, raise your right arm. If it doesn't matter, you can raise both. All right. All right, questions for practice on this one, 6 and 7. Yes.